Hey everyone. Today we're doing 10.3 coordinate proof using uh, stuff. We're going to focus these coordinate proofs on triangles. And what a coordinate proof is it's essentially proving something about a triangle or some property of triangles using uh, what you guys have been calling lately math, right? So instead of actually putting it out and visualizing it, we can use coordinates for all the points, and then we can draw conclusions using our coordinate geometry. So here are just some tips for coordinate proofs. Usually it's a smart idea to involve the origin somehow, right? You can position figures anywhere in the coordinate plane. However, the origins are really handy because the origin has zeros, and zeros are really easy to work with mathematically. So, for example, subtracting zero is real easy, adding zero is real easy, dividing by zero, multiplying by zero. So try and do that. Similarly, use an axis if at all possible for one of the sides, because that way then you can again it's a zero value, so it makes things easy to work with. Here's an example of one. And these proofs won't be two-column proofs like we've done in the past. This is more like a paragraph proof where we just kind of give a series of logical steps. And they'll be more formalized when we get to quadrilaterals in the next section. So this example is just, we have angle B is a right angle. We have triangle ABC. And then it says D is the midpoint of AC. So that's our setup, right? We have triangle ABC, and D is the midpoint of side AC. That's all we got. Oh, and it's a right triangle, where B is the right angle. So AC is the hypotenuse, right? We need to prove that the area of triangle ADB is 1/2 the area of triangle ABC, right? So this is half of the triangle. So we can go ahead and assign a coordinates. What we're not going to do is assign like really specific coordinate values, because this triangle could be any triangle, right? That's all we know about the triangle. So we want to generalize a little bit here. So what we can do though is place one of the corners on the origin. So that's what we're going to do here. This is kind of our setup. Again, there's multiple right answers for these sorts of things, but if we place the origin here at the center, or the angle B is at the origin, then that means we can put angle A up one axis, or side AB on one axis, side BC on another axis, and then we can give some numbers here. So the height of AB, right, the length of AB, we're going to say is 2J, and you'll see why here in a second. Similarly, the length of BC we're going to put as 2N. The N is just a variable. The J is just a variable. The reason why we're doing two of whatever it is because that makes the math really easy when we go to do a midpoint. So that'll just pop right out. So the first thing we're going to do is calculate what is the area of this triangle ABC. Well, we know that the formula for the area of a triangle is 1/2 base times height. The base here is 2N, the height is 2J. So 1/2 2N times 2J. One of these 2's cancels with the 1/2, and we're left with 2NJ. Okay, so that's our area. And then let's calculate where point D is. We can do that using the midpoint formula. Hopefully you guys can plug in some numbers here. But you may have noticed that if you, we can do the midpoint formula, but as it turns out, point D here is N on the x-axis and J on the y-axis. So it's NJ. So therefore, we can calculate the height of triangle ABC, or ADB, sorry, ADB. So the height of that triangle, they're going in this direction here. So what's the height of that triangle? Well, that's just N. The base here is 2J again. 1/2 base times height gives an area of Jn. So therefore, is Jn 1/2 of 2Jn? Correct, yes it is. Okay, so we've proven that. Okay, let's do another example. This one's on the coordinate plane. We're given points A, B, C, and D, and D, E, and F, we have to prove that angle ABC, so ABC, is congruent to angle DEF. So essentially, we can create two triangles from these. So we can create this triangle is congruent to this triangle. If we can prove these two triangles congruent, we can use the corresponding parts of congruent triangles are congruent property to say that these angles are congruent, right? So how do we prove that triangles are congruent? Well, the easiest way would be probably, unless it's a right angle at this point, the only real tool we have is side, 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 right? Because we can calculate lengths in the coordinate plane. So I can calculate what AB is, I can calculate what BC is, and AC. Similarly, I can calculate DE, EF, and DF. I'm just going to extend down here so we can see it. So AB is 5, BC is square root of 17, and AC is square root of 10. All right, DE is 5, EF is square root of 17, and DF is the square root of 10. So are these triangles congruent? Yes, the triangles are congruent. Therefore, we can conclude that the two angles are congruent. The two corresponding angles are congruent. Okay. Similarly, sorry about that. I had to cover up the answers, so hope you didn't see those. So we're given that we have points J, K, L, and M. We're given the fact that R is the midpoint of JK, and S is the midpoint of LM. So we have a midpoint between these two guys and a midpoint between these two guys. We need to say that angle JSK is congruent to angle LRM. Similarly, we're going to use side, side, side to set these two triangles to be congruent. However, we need to figure out where point R is, right? So we need to figure out where point R is. We also need to figure out where point S is. We can use the midpoint formula. So R is the average of J and K. Average of -4 and 0 is -2. Average of 0 and 5 is 3. S is the average of L and M. So that's, what is that, 1 and -1. Cool. Here's a picture if you graph it out. But we can do this without graphing. We're still using just our coordinate geometry, right? So then we can use the distance formula to find all those lengths. JK is the square root of 32.
Just kidding.
KS is the square root of 37. And JS is the square root of 29. LM is the square root of 32, this thing's the square root of 37, that thing's the square root of 29. So hooray, we can say that all these sides are congruent. Therefore, we can say the triangles are congruent using side, side, side. And then we can conclude that any corresponding angles that we want are congruent because CP, CTC. Okay, that was pretty similar. See if you can do this one. It is pretty similar. Okay, same sort of deal. We have 6 points here. We have we need to prove that angle BCA is congruent to EFD, so we can make two triangles. ABC, DEF. And again, side, side, side is the best way to do this. There really wasn't enough room here, so I hope you're able to power through it. All right, when you write a coordinate proof, why might you assign 2P as a coordinate rather than P? And we discussed this before. This is pretty much when you have a midpoint of somewhere, right? It's a little easier to use 2P than something else. How are these coordinate proofs different than other types of proofs? Well, here we are in the coordinate plane, so we can use our coordinate algebra, essentially, in order to draw conclusions. Okay, I'm going to pause here and put up the little 10.4 in a separate video. So, see ya.